Hi, everyone. Well, welcome to our next Quant Club. I have with us here today Mike Phillips, who is our Chief Data Officer at Numerai. We're going to be talking about just some of the development we've been working on a new feature set. Oh, hey, Liam. It's good to see you. Liam, a former employee here, and it's good to see him. I haven't seen him in a while. So yeah, before we begin, if anyone has any questions, topics they want to bring up, we did promise we'd talk about aliens, so we're going to take the temperature on what is our subjective probabilities of aliens given recent disclosures. So yeah, I would love to hear all of your opinions and see how wildly we diverge, or if we can reach some sort of like ensemble consensus.
Has everyone seen the latest whistleblower interview? Have you seen it, Michael?
I have, yeah. I just finished watching it, actually. You assigned it as homework, so I was trying to get that.
Of course.
So does that change your subjective probability of things?
I mean, there was like pros and cons. Like, I don't know, the guy does seem reasonably intelligent. He doesn't seem to be thinking that he's lying. That was my temperature. But he also said some things that weren't, he was claiming to be like, a physicist, but he was very like hand wavy with like extra dimensions and quantum, like you would expect from someone who's just watched a couple of YouTube videos on it. So I feel like I have to discredit him a bit on that.
I thought sort of the same thing, but then I'm like, wait, is he just like an undergraduate physics? Is it just like an undergraduate physics degree? Because that might make more sense.
I don't know. I'll be honest. It put me more in hype. Before I was a staunch, everyone who thinks aliens are real is crazy. It's all sci-fi stuff. But after watching the hour-long interview and listening to him talk, I'm more excited about them than ever. I'm excited about their potential to change the world. Yeah, very alien positive today.
What about you, Liam?
I was convinced like a year or two ago. I remember there's a New York Times article on like multiple independent military organizations are seeing like flying objects changing direction super fast. I've been convinced for a while. Yeah.
That's like TikToker being convinced like years before us.
It's a topic I've been really interested in for a long time. I actually wrote in my admissions essays to colleges that I wanted to work on reverse engineering UFOs, because I thought that was pretty much the coolest thing anyone could ever work on. Slightly embarrassing in retrospect to actually have put that in a college admissions essay, but
did you ever get any feedback on that?
No, I didn't. I mean, I had like my teachers and stuff at the time. That was one of many things I said I wanted to do. I had so much more less out there things, but it was definitely something I've been like, yeah, just working on like a technology, working on something, trying to understand something that's like way beyond what we have seen. Just sounds like the coolest thing one can do. And so in some sense, I've been working on similar types of problems in some way, like working on the brain and the stock market, working on trying to understand systems that are like beyond our technology. It's been sort of a theme, I guess, in my life, but still, if I could get my hands on a UFO, that'd be pretty fucking cool. Anyone else has any objective?
A science foundation, so maybe in your spare time, you can assist them.
Yeah, although from that testimony, it did sound potentially dangerous. He mentioned that some people in trying to work on them have been like injured and killed, so it's a little scary.
Yeah, those my favorite bombshells were like, yes, people have been murdered by extraterrestrials to his knowledge, and like the Catholic Church is involved.
Of course.
Maybe we should move to rain before we get involved in a
Sure, yeah, we don't want to
as soon as you mention the Catholic Church, I'm like, let's talk about the data.
Yeah. Cool. So yeah, or just wanted to, if anyone has any further updated subjective probabilities, we'd be curious to hear about that. But let's move on to some more Numerai related stuff. Assuming that the aliens don't completely upend our society within the next decade or so, this will hopefully be very important. We're developing a new feature set that's trying to take advantage of more like time series information. Right now, the problem we give to you is basically you have point in time features and you're trying to predict returns over the next like 20 or 60 days. And those features mostly don't have any sort of notion of history of their historical values of the features. Some of them are probably like momentum like features, so they do are looking at like changes over time, but a lot of the features are just kind of point in time. And it seemed like a natural extension to basically have some sort of history of the features to sort of learn how that feature has changed over time, and if that features change over time is relevant for predicting at the current time. And so I'd been developing a way to basically fit filters on historical values of each feature, and then filters that are learned in such a way that they sort of help when added to the current set of features. And
maybe I can just pause quickly on like what the reasoning is behind this before you, because yeah, you're gonna talk about all these filters and stuff, and I'm not gonna be much help. I'm just gonna be asking questions at that point. But yeah, like I guess to make it more clear, like why we started thinking about this was like the goal is always to give the users as much information as possible about every stock. So ideally we would just give out every raw feature that we have and let users do anything they want with them, get as much information as possible. But there's a couple of problems with that. One is that, yeah, we don't want to give out 1 million features. And the other is that they don't have stock IDs because we have this encryption requirement. So users can't actually do time series transformations on features themselves. So it kind of falls on Numerai to do these time series transformations. And maybe everyone knows this, but just to like kind of clarify what that means, like one example of a feature might just be like a super naive feature would just be price, like the price of a stock. A time series transformation on that would be like the change in the price of a stock over the last 12 months. You can do a lot of other things with that. You can take what the max price has been over the last 12 months. And then you can do the max, minus the min. You can do the max over the last 24 months. There's like an infinite amount of time series transformations to do. So we were kind of thinking, okay, should we just do every single time series transformation on every single data point we have and give that out? And the answer is no, that's kind of a bit crazy. So the question basically became, how can we give out as much of this useful information as possible, and without it being, 1 billion features? So that's why MDO started thinking about this.
Yeah, that's right. And this idea of trying to learn filters was something that I had worked on previously in like my neuroscience research for my PhD and whatnot. And the idea is you're trying to learn basically just the values that you can weight each historical value of a feature by in time. So you're learning sort of like how a feature value change over time can impact its performance, how its usefulness as a feature at the current time. So you might see, and we're learning filters on various time scales too. So a fairly short time scale, like 20 weeks, like a 2-year time scale, and maybe like a 5-year time scale. And interestingly, so yeah, in the longer time scale, like the 2 years and 5 years, the filters you can actually see kind of like yearly periodicity things. And so the filters are telling you something about how the current value differs from historical values, which seems like a very potentially relevant piece of information for a feature. Just a feature being high is one useful piece of information, but another potential use for information is it high with relative to its past? Has it recently gone up? Has it gone up over the last few weeks? Has it gone up over the last like 2 years? All of those sorts of things seem relevant, but yeah, rather than giving every possible value, we wanted to sort of learn them in a way that is most additive to our current feature set. And so, yeah, basically I coded this thing up in PyTorch, and basically we're learning filters at various timescales. And then while they're being learned, you're also learning a model that uses those filters and just the raw values of the features. And to try to predict the target. So the filters are learned to add to the current features and also to try to predict the target. And it's a lot of potential like parameters to learn, trying to learn all these filters. And there's sort of reduced rank things you can do. You can sort of learn like a basis set from which all filters have to be constructed to greatly reduce the number of parameters you have to learn. And like you can do some like smoothness parameters so the filters vary more continuously over time and look a bit more believable. And so yeah, the long story short is that the filters actually worked pretty well in correlation because they were learned in sort of a mean squared objective on a target, and they generalized quite well. And so so we're pretty excited about it and still are, but there ended up being some wrinkles when I handed them over to Mike to investigate for incorporating into our feature set. This is basically the reason why we haven't yet released it. Mike, do you want to talk about sort of some of the steps you found?
Yeah, and it sort of ties in with the way that like I guess the data team versus the research team thinks about releasing data. Like I was saying, my job is sort of to give out as much information as possible on the grounds that it doesn't affect the encryption, and on the grounds that it's like a safe thing to give out. So what does not safe mean? Well, in the case of these rain features, as Michael was saying, he basically constructed them in a way they were learned to be additive and to result in models that have good correlation with a target. They're that way by construction, and they did that job extremely well. But what ends up happening is, so from a user perspective, you would take those features in, build a great model that has extremely high correlation, and then it actually ends up hurting the hedge fund. And there's a few reasons why that could happen. One of them is costs. So if these features are learned in such a way that it encourages models to buy stocks that are extremely expensive to trade, you might be very right. You might be exactly right about that the stock's going to go up a lot, but it actually costs Numerai so much to trade that stock that it's not even profitable for us to make that trade. And so that's one example of something that is like, it's sort of I would say a misalignment between what's happening in correlation space and what's actually happening on the hedge fund. So what happened is we did all this research and basically found that these features look incredible. They're going to help so much. And then when we actually checked what would happen in like a back test, they didn't help. In fact, they hurt. So yeah, that's the nature of the long delay. We're trying to rethink how to construct these in a way that don't have that bad property.
Yeah, and sort of in that research, we learned a lot about just what to sort of look for, and we ruled out a lot of ideas in like, why are these features working so well in correlation and not working well in a backtest? And it wasn't anything simple like they don't work well in the tails and work well in the middle. They seem to work pretty well across the distribution. It seemed more so to do with some sort of like factor exposure. Yeah, there's sort of an interesting thing that you'll see. So like the targets you train on are all factor neutral. They're all neutral to the sort of like basic borrow factors. But a model you train on the targets doesn't necessarily make factor neutral predictions. And that's sort of a disconnect that you always see because factors change and shift over time. And so there's no guarantee that your predictions will be factor neutral. So even if you train a model on targets that are factor neutral, doesn't mean the things that are going to be learned are factor neutral. And it did seem that these features did tilt a little bit towards tilted models towards having a bit more like momentum exposure. Which is maybe not surprising given that they are sort of time series filters. And so, yeah, so I mean, we're going to work on sort of a newer version of these features that is more aware of some of the things that we think are important. It didn't seem to be the case that these features were, say, like not good at more liquid stocks. I mean, this is another constraint we have as a hedge fund. in order to move lots of money around, we have to be able to trade stocks that have a lot of volume, have a lot of liquidity. And if your model only helps on illiquid stocks, it might look good in correlation, but it could produce predictions that aren't really actionable. And we have some of our targets are, especially like some of our new targets, are corrected for, or at least somewhat adjusted for liquidity. But it doesn't necessarily solve the problem completely. And so, yeah, so things like liquidity, things like factor exposure, trying to be good at multiple targets. These are all some of the ideas that we're going to incorporate into the next version of the features, which I'm actually going to start working on pretty shortly.
This really ties in. It like explains a lot. We put out like multiple targets. We've talked about this a bit before. We put out multiple targets. We have like true contribution. We have, top bottom 200 correlation in diagnostics. We have things like FNC. We have all these different tools, and they're all trying to get at this problem of what is pure correlation against our main target missing. That's like not quite perfectly aligned with what the hedge fund wants. And so we'll find something like that, and we try to reveal that information through a new score. So for example, if we don't want too much exposure to any one feature or any one factor, then we'll say, okay, well, let's at least tell users what their FNC is, their feature neutral correlation. And if they can be good at that and they're good at correlation, then it's something that's we're going to be more likely to take advantage of. And same thing with like top bottom. It's like we found out that the tails end up being picked up more than we thought. And so that's why we made this new Numerai core, where we kind of accentuate the tails more in correlation. So yeah, this is like a pretty consistent theme of trying to make this kind of hedge fund where you have like a separate tournament that's being scored a little bit differently than how the actual hedge fund's being scored. So a lot of our job is just trying to keep those in alignment by giving you all these different scores. And now it also comes into play when we're trying to give out features that keep things in alignment.
Yeah, and sort of related to that issue is about multiple targets and some of the things we're thinking about for creating new targets. I mean, we're talking about this idea of like these randomized targets, and it's an idea I would be curious to hear other people's thoughts on. One of the ways we think about targets is that targets are sort of like valid strategies that like a hedge fund could employ. Like hedge funds are constructed in all sorts of different ways. Some they choose to be neutral to certain factors but exposed to other factors. Some choose to try to be neutral to everything. We're more on the sort of try to be neutral to everything, but that doesn't mean there's not a signal, an alpha to be found in some of these other strategies. And so the idea is that if people are training on different targets, they're sort of training like a different strategy, and then us at the stake weighted level are ensembling all these different strategies. So we're ensembling lots of basically potentially all possible strategies at the limit, and our sort of overall strategy is this like huge ensemble of all different possible valid strategies. And so Mike, do you want to talk a little bit about this randomized target idea that we're thinking about?
Yeah, it's kind of a crazy one. Like, so like every time that we do a research cycle, we end up finding a handful of new targets that seem to help a lot. And even if some of them will help more than our current best target, and then we'll put that out as, it was like Nomi and then Ralph and then now Cyrus. And these are like strictly better targets than the previous ones. But for almost every target that we build, we end up finding that if you build a model on it and add it in at 1% weight with the current best target. So for example, we build basically any target, build a model on it, add it with 1% weight to a Cyrus model, that ends up performing better. And oftentimes actually always in correlation and usually in back tests as well. So the idea is, if almost every target that we build ends up working, can we just make like 1,000 of these targets? And can we automatically build them in some way and test them and make sure they're still additive? And basically, instead of having to make all these research cycles and have people come up with new ideas for new targets, we can just construct every possible target there is and give out all the ones that are going to be beneficial. So that's the idea. Is that pretty clear? Pretty vague how that happens, I guess.
In chat, Correlator's asking, is it correct that the new targets are neutral to new risk factors, but TC is still calculated with respect to old risk factors? If so, how could current TC benefit from training on new targets, user's perspective? So training on the new targets, we found training on the new targets works fine, works well for both our old and new optimizer settings. The new, yeah, it's true. The new targets are neutral to some new risk factors. And I mean, the old one, the new ones are sort of additive to the old ones. It's not like they're completely different. So it's basically neutral to more things. So it's how does that impact your TC? I mean, largely it still just depends on are you predicting, are you sort of correctly predicting returns? Are your predictions sort of translating into a portfolio returns? And if you and that is, yeah, sort of true whether with the old TC. And so basically, I mean, if you're training on new targets, it's sort of your signal is going to be more different than a lot of other people's training on old things, and that you're going to get a TC benefit mostly from that, I would think. Your signal is different and also predicting returns pretty well, and so it should be very additive to what other people are doing. And that, I think that's will be true regardless of the optimizer settings. So yeah, I kind of think every time we release targets, there's we're sort of unlocking a lot of TC and a lot of alpha for people, because these things take a while to be adopted. And so the first people who kind of are able to make good models using new targets are going to be able to make models that are differentiated. Yeah, I mean, generally to be good at the competition, you need to be good and different. And you kind of have to be both these things. If you're just different, your model might get good TC for a while, but then it might get very negative TC for a while too, and kind of wipe out your gains. And so to get sort of consistent, you need to be both good and different. That's, yeah, our whole incentive structure is really to encourage those two things, and that's a tricky thing to do, to make people both good and different in the way they ensemble well. TC is our sort of like best attempt at trying to do that, and it's from our perspective, it's been fairly successful in getting models that are quite different. I mean, if you look at the top stakers on the top of the leaderboard, the correlation with meta model is fairly low now. I mean, I remember back when a lot of the top models were like 95% correlated with the meta model. And so those models, while quite good, weren't very different and weren't very additive. And so that's the sort of danger in just having a sort of easily trainable objective that everyone is using, is people sort of converge on similar solutions. And there's not enough diversity to sort of get the benefits of this large community ensembling effects that we're after.
There's been so many iterations of this as well. Like even before you and I joined, you know, you hear about our originality score.
Yeah.
Where people, it's like the first person to submit a certain type of model, I think got some benefit. I don't even know. It was, again, before I joined. And then when I joined and we started working on like meta model contribution, MMC. And even that went through a few iterations. One of my favorite like heuristics or intuitions is sort of just like model performance times 1 minus your correlation with the meta model is like a reasonable proxy for how different and how good you are. But then we just decided to go all the way with TC.
Yeah. Yeah, I've been seeing people asking a lot of questions about TC and staking on the forums, or on the forums, the not Rocket Chat anymore, on Discord. And Andy's saying the originality score, you had to be the first or were simply rejected if you didn't meet original threshold with change with each submission from somebody else. Yeah. Log loss. Yeah, that was yeah, log loss was rough. If anyone remembers that, where you could have a positive correlation but negative log loss. That happened to me several times. It's very frustrating. But yeah, so people are asking about TC and staking, and if some people are sort of overstaked, and if we could how your TC will sort of change with stake. And Wigglemuse, Andy has been doing a good job at like answering a lot of those questions. And yeah, I mean, one thing to point out is that the dropout thing that is involved in TC calculation is essentially setting your stake to 0. So you are getting gradients as if your stake was set to 0 half the time, and gradients at your current stake. It's just to sort of try to, and this is happening to everybody simultaneously. So it's and the final score is an averaged over a bunch of rounds of this. It's to try to get a overall score of what your gradient is, or would be with respect to lots of different possible peer groups, to try to sort of uncover just your, make it a bit more unique to you and your signal, and under lots of possible situations, as a way to sort of better approximate what you are really contributing. And yeah, I still think people don't need to worry too much about how their stake is interacting with TC. I mean, when I did simulations to try to find out when the gradient really starts leveling off, yeah, you need to be a pretty large part of the staking pool for that to really happen. And that sort of assumes that that things are always pointing in the same direction, and it's not. That's definitely not the case. I mean, this market is very non-stationary. The sort of optimal arrangement of stakes every round, in a sort of overfit sense, is very different. And so by sort of just updating them very slowly through the stake updates and payouts, we're sort of moving towards a solution that should work well on average. But the actual gradients in different rounds, just due to how the market turns out, can be very different from round to round. And so in one round, so yeah, I mean, it's possible like your stake is too high for a high TC in one round and too low in another round, just due to how market dynamics shift and change. And so it's sort of very hard to tell you if you're overstaked or understaked on a single round, because that can really change pretty dramatically. And so yeah, basically the payouts are trying to move towards some like equilibrium, but it's an equilibrium that's never really going to be achieved, because the market is not stationary and always changing. We're just always sort of moving in a better direction. But yeah, there's no sort of I don't think there's ever like a real point like this is the optimal stake distribution forever. I don't think that really makes sense.
So there's been a lot of speculation about like what's the best way to kind of predict your TC? What scores can you look at to try and estimate what your TC should be? I think there was a forum post sort of recently even that was just showing like correlation with the meta model versus TC, and trying to see if having low core with the meta model consistently gives high TC or not, this sort of thing. What I'm curious about is, I know people have looked at this in the past, but I wonder if anyone's looked at it in like the last month, because before this month, since TC has come out, we've kind of had a lot of consecutive really good high payout rounds, which may have a very different behavior than in the more recent rounds, which have been like very heavy burns. So I wonder if there's if there's a lot more insight into saying, okay, well, in the past, this model that was very safe and just prevented a lot of drawdown, it was having really bad TC because all these models that were sort of like overfit and doing really good in easy times, we're getting all the TC. maybe now these sort of hedged models have had their time to shine. And I wonder if that shows up in anyone's analysis. Have you looked at it at all since your original research, Michael?
I haven't looked at it recently. Yeah, I would be very curious to hear from anyone who wants to share about any models they have that have performed well over like May, for instance, and what sort of things, if they want to talk about in vague terms, those models are trying to do versus some of the models that might have burned.
Yeah, the last month's TC leaderboard would be fascinating to see what kind of models are there.
Yeah, I mean, it was a tough month for quant, and just the markets were behaving very differently than they have with respect to the features. Yeah, anyone have anything they want to share? You're welcome to go off mute and. Quiet group as usual.
Maybe everyone here has just been burning for the last month.
Yeah. So it's, yeah, I think in some of the research we've looked at it, we're working on this new criteria for splitting trees, where you can try to optimize for splits that work well all the time. And I think this kind of brings up, and some of that work did look like they could have reduced but not eliminated sort of recent burns. But yeah, there's always this sort of risk reward trade-off thing where if you have a model that works well, the more often your model works, the sort of smaller it's going to work. There's only sort of a small number of things that work all the time, and so if your model works well all the time, you're sort of limiting yourself to a sort of small slice of returns. And the sort of more the more risk you're willing to take, the more you're trying to and risk meaning the more times your model is not going to work, the more potential rewards you can get. And so that's sort of a natural way you get the sort of risk reward trade-off for models. And you can sort of you can train towards these things directly, and you can sort of incorporate these things into how you train your model. And so if you try to only find solutions that are giving you positive return or positive correlation in every era, you're going to find that sort of your maybe average correlation is a fair bit lower. And where if you kind of go to the other extreme, if you find things that work really well 51% of the time, you might have a higher average correlation potentially, but then you will have like these huge burns. And yeah, it's given the way things compound, maybe a more conservative solution is best. But yeah, it sort of depends on to some degree your risk tolerance and what you're seeking out.
Yeah, one of the other things along these lines is that I've been interested in, I haven't heard too much from, is how people have used the stake-weighted meta model predictions that we give out. Like if you were to look at the stake-weighted meta model predictions over the last 2 months, it's probably doing much worse than it did in the previous year that we gave out. I'd be really curious to find out if anyone has delved into that and really seen like what it got wrong, and if they know how to like construct a model that fixes that specific issue. Yeah, I haven't heard too much about it. Hopefully someone will make a forum post one day that explains their thought process.
Yeah, I talked a little bit in chat about ways to try to basically just, yeah, you're trying to train a model to like that you can add to the stake-weighted meta model, so that you incorporate the predictions as part of the objective, so that if you are just like 1% of the stake-weighted meta model, you're trying to optimize the predictions, given that you're just like adding like 1% or something to it. I think that's a great approach. I mean, you could do things like orthogonalize the targets to the stake-weighted meta model. Yeah, there's I think people have so much more data now. I mean, just since we've gotten out the test set and so much more information with the stake-weighted meta model. I think there's tons of interesting things people could do. And yeah, and especially with all the targets and whatnot. I know Andy's talked about in the past some of the interesting stuff he was doing with using multiple targets, like averaging them together and whatnot. Yeah, I mean, there's various things you could do to try to look for like agreement between the targets, try to train such that you're good on multiple targets, or sort of minimize your worst target performance. There's lots of fun sort of data sciencey things. I would be curious to see what other sort of approaches people have taken. Okay. Really, no one wants to say anything.
I find it funny because one of the top comments on the survey was people wanting to interact more. But then when it comes to doing it live, then no one wants to do it.
Maybe we should require everyone to be on video. So we could see all of your faces, and then you'll feel more exposed and would be more willing to talk.
Can you hear me?
Yes.
Okay, I had my broken audio for a minute. So I don't have anything big to add, but a couple of things you were just saying. I did make a set of models where I used the meta model historical things, not in the way that you would think of first, in which you would like subtract from, and try to make up the difference. I just made that the target, full stop.
Mm-hmm.
But then I neutralized the result, and I did something else, which I can't even remember what it was right now. But I'd have to check. And this was, I don't know, they've been running for about 2 months, maybe. And these are on my data transformations. So even though I'm making the meta model the target, if I did it in a very straight way, I think I would end up quite close to the meta model. But some of them are still, 5% correlated or something, because the data that I transform is so strange, which is probably just random noise. But anyways, some of them, the more normal ones of them, did really well right at the beginning. I was like, oh, this is going to be awesome. I'm just going to make it like the meta model until it stops working, because I figured, the meta model does well for you guys. It'll be an interesting test anyways. And they started off, they were just getting, but as soon as the burn started, they just all tanked. And then I adjusted some of them to be a little weirder, and then they're sort of half and half. So I haven't, staked on those or anything, but that was just an interesting thing. But yeah, they immediately tanked. And everything that I did, some of the things that I was trying to do a sort of a diverse approach before the big burn recently, where I'd have a lot of different models, and I would expect, about half of them to do well and half of them not to do well. Or I was shooting for something like, 60-40 or even 55-45, just enough to get a consistency overall, would it be positive. And that was maybe sort of working, but then when the burn started, they sort of all went. Then it was becoming like 70-30 negative. And there's some that were good. And then I came up with some new, weird stuff. And I have come up with some models that have done very well in this burn period, but I don't know how they would have done before that. So probably they're just, bad models in good times. And this is what some of my frustration that I was arguing with on Sentient the other day. This period that we're in now should be very valuable information in terms of, and it will be, like in terms of core. But if I come up with something a month from now and I'm like, how would this have done on TC during the burn? And how would this done on TC 6 months ago when there wasn't a burn? And I can't find out because I can't backtest TC in any sensible way that I found. I mean, we've got some proxies, but the the stuff I do is just too strange, I think. But the correlation and the other scores just aren't predicting TC at all for me. So the only way I'm figuring out how TC works is in live testing, and anything that's happened in the past I can't. So I just got to wait. So I don't. It's very good. I'm looking for something that when it tanks in a bad period or in a good period, that it's not just a 100% reversal, and that's I
Right.
think a lot of the problem. Even with the good models, you try to get them to do consistently well. They don't have to be the best, but then when things turn around, they just become the worst. So the range is like from just god awful to 60% or 70%, some acceptable number if it stayed that way all the time, but they're not going, they need to go up to 100% when they're good. So I'm struggling with all that, but
is there anything you want to share about the models that have done better during the burn period, or the sort of things you've looked at that seem like would have done better?
Well, you were just talking about how TC is trying to achieve a balance between being good and being unique, and I think most people probably start from being good and then try to become more unique, which is what I used to do. But the stuff I've done in the last year is definitely starting from just being as weird as freaking possible. They're all 0% correlated. Some of them are up to 40 and 50 now, and then trying to de-weird some of those so they become better. And I just keep changing things so often that I just don't know where I am anymore. So I'm very much in research mode. What I do is because, and I've also been trying to come up with methods that aren't like really brittle. They're not like super optimized to what's going on. I'm trying to come up with general stuff. Like when you guys come up with new data and new targets, I just switch all my models to all of that the next day practically. They just suck it all in, and what comes out. So I keep a little bit of records, on this era change, and they don't change that much. So it sort of does absorb them in a way. The stuff I'm doing is trying to like even out all the features. So I'm not like, super reliant on anything and stuff and sort of automatically taking care of redundancy or whatever. And the downside, of course, is that any super feature in there, it's just sort of not going to pay that much attention to. It's just looking at the general structure of the overall data, and it's using all of the targets at once. I mean, you add 8 targets, I just add 8 new targets that get mixed into my ensembles, and I just go with it, so. But no, I don't have any good tips that would make sense to anybody else at this time. I do have one idea it would take me 45 minutes to even explain it, and no one is going to do it. So I'll just keep that in my hat at the moment. But
a couple of things that stand out to me are, I remember maybe it might have been a couple of years ago now, Bohr talked about, he showed this kind of like good errors, bad errors dichotomy, where basically it's very easy to make a model that's like, it does really well on 50% of the errors, and it does really bad on 50% of the errors. And then of course and that's how most models look. It's like, if you do something that does really good in drawdowns, or when it's a burn period for everyone else, it's probably just going to do the opposite when it's easy for everyone else. And the tricky part is isolating that razor thin edge that is kind of good in all weathers. But yeah, that seems almost impossible sometimes. The other question I had was, I'm really curious to know how well you could like reconstruct the meta model. You said like you use the stake weighted meta model predictions as your target. Did you find that out of sample you could reconstruct it very well, or were you still missing? Maybe you were 80% correlated and there's still 20% where God knows where it's coming from.
You can easily get up to 80 or so. I mean, I was getting 80 or so.
That even on like live data. So so in the website, it would show that you're 80% correlated with the meta model out of sample.
Because it basically never had more than a round or two of core losses until recently. And then you sort of deprecated, got rid of V3 anyways. So I just retired that. I probably should have kept it around to see, because its TC was always lousy. As soon as TC, it never got good TC, but it's been consistent on core for years. But I just don't need it anymore. And of course, I'm not paying very much. And the new core, I don't know if it's any good on that. So I figured now it was time to get rid of it. And that was always at 80% live, not using meta model predictions until I took away the bad features, which you identified, and then it dropped by about 3%. So it's been running. So I mean, that model was pretty normal and that was easy to get to. Anyways, getting back to the meta model as a target, I don't do any version of that where I just take your features and predict the meta model straight. If you did, I imagine it would be pretty high. And I'm also neutralizing it at the end to get away from the most correlated one I got is about 50% now, but none of them are which is not neutralized. I took neutralization away on a couple of them because they were just a little too strange. But I am not using your features as given. I am transforming them first in ways which are quite destructive. So, and that's basically my way of getting away from the meta model. I'm just not that interested in copying the meta model. If I had more slots, I actually using up all my slots now. So sort of experiments, I'm kind of curious, but I'm not that curious. They get fall off the radar, but
I do like that. I mean, like I've tried reconstructing the meta model myself before and see how close you can get. And you can't get as close as you would expect if everyone was just using the features as provided. Like some people must be doing destructive things because the models don't actually predict the meta model that well.
Yeah, I mean, it's changed a lot. I mean, like Arbitrage used to say, I am the meta model. And he was trying to get basically, because it was working, right? He used to be 94% correlated. He was more correlated than the example predictions at the time, which were very correlated back in V2. But since TC, I've been trying to get TC and failing at it. But my stuff has become significantly weirder since then. One thing I am doing, and just in the last few weeks, I don't know whether it's got any value or not, is because I make these giant ensembles where I use all the errors. I use all 1,000 errors we've got and make it. So I make 1,000 models and then ensemble those. And I came up with a new thing where I filter the ones that I put in the final ensemble based on the structure of the predictions that they come up with for that era. In other words, so I make 1,000 sets of predictions for the live, and then I'm normally just going to ensemble those together. Pretty much the straight average. I used to weight them, but straight average actually seems to work better. But now I'm doing a thing, or I'm additionally doing a thing for a version of it, where I throw away maybe 80% of the stuff that I just calculated because the resulting predictions from each individual era don't fit this structural form that I am expecting. And that's sort of the weird idea that would take me a long time to explain, but I'm hoping there's a little magic there because I noticed a pattern that's predictable, that's sort of outside of the normal modeling flow. It's just like a structural thing. And I was like, what if I only included the eras in the ensemble that fit that pattern, which I'm seeing happen? So I don't know if it's nonsense or what, but it's hard to tell anything right now because it's such a burn. We need this to change again. And that's going to frustrate me when it does change, that I can't go back, like I said, and check really well how things would have done, because we don't have that many really great burn periods. So burn periods suck to be in, but they're great to have in the data. for research. So
Yeah, I think that's one of the huge things that we've done recently, or somewhat recently now, was just giving people resolved round targets. So you actually will have, like, you can actually train on these new, very useful burn periods.
right.
Which, yeah, that's so
One
yeah.
thing, those new features or those filters you were talking about adding, time series, so that would preclude having them, like some of your other newer features, in the earlier eras, right? They'd have to start at some point after they have a time period existing before that, don't they?
Right. I mean, yeah, if they have like a 2-year look back, they can't start at the beginning of time because we don't have any features prior to that. But yeah, so they would have probably a fair bit of nans in them, which we would either fill or give out as nans, depending on yeah. For most of our investigations, I believe we were filling them. Is that right, Mike?
I've tried both. Yeah, I mean, obviously we give out nans if the whole feature is nan. It's like the entire, so like for the first 2 years, for example, if it's a 2-year look back feature, so it's just all nans, they just stay as nans.
Okay.
Yeah. Then yeah, because of these stocks, it's like if the stock didn't exist for the last 2 years, then and that's why. And but there are other stocks that do have values, then we just fill those.
Oh, here's a question. One thing I do is, or have been doing, is I filter out rows in the eras that don't have all the targets. Because again, I use all the targets, and I just thought, it's just easier if I don't have to deal with missing targets. So, and it used to be, I don't know, 200 or 300 rows, but the last just 3 or 4 weeks, there's about 800 rows that I'm, and when I say 3 or 4 weeks, I mean I'm taking the validation data that you provided, and I don't look at the ones until they have 60-day targets. So there's actually like from 3 months ago or something. But like era 1053, 1052, 1051, I'm suddenly deleting 800 rows worth of data instead of 200, and that's new, which means that a bunch of new rows are not getting targets in the most recent eras. Is there any reason for that? Do you know what I'm talking about?
It sounds like it lines up with the, I'll look a little bit closer, but it sounds like it lines up with like an index restructure where the universe has changed a lot, and there's maybe some vendors don't have the data needed to make those targets yet, that kind of thing. But
right.
Yeah.
So it's not any market reason, it's just a data thing, probably.
Right.
Yeah.
So correlator ask any word on LLMs being used to generate features.
Yeah, do you have any thoughts on LLMs, Mike?
I mean, it's not that much of an update. I was looking at this, seeing if I had anything new to say about this, but then I read like Richard's forum posts from about a month ago, where basically, yeah, and he basically sums it up there. It's like they're kind of, okay, the short answer is yes, we're kind of looking at this, but it's not going to be in this rain release. It'll be either later this year or even next year where these might actually go out. But I still think people can do this on like signals. Really interesting. It's a really interesting approach for signals. And yeah, Richard highlights it really well in his forum post, where he basically says there's like 2 paths. One is you can just like prompt ChatGPT directly and just say like, pretend you're a the best stock analyst in the world. Do you think this stock is going to outperform over the next month? Yes or no? Based on some news or something like that. And then the other path is like a little bit deeper and maybe more tunable, and that's like the embedding space. Are data vendors ready, willing to provide these? The main thing is us like getting like news data so that we can do this ourselves. We're not like, yeah, we'll probably just be constructing these ourselves from like either headlines or news data. I don't think we'll be like using someone else's custom built LLM features because it's just so new. Like there's very few vendors that are even doing this yet.
What I saw something interesting related to this. I needed to dig more into it. it was basically comparing, trying to do better benchmarking of some of the more recent LLMs versus some like the Flan T5 from like 2019. And they were finding that in a lot of metrics and a lot of tasks, these older LLMs are just as good or better than even some of the more recent ones. And so, yeah, I mean, it depends a lot on your task. And I mean, people have been doing like financial, like models fine-tuned on finance for several years. And yeah, trying to construct features out of that. Yeah, I mean, so the it's not clear to me that some of the new stuff is even much better than stuff that's been around for 5-6 years. And people are just more excited about it because it's entered the consciousness through like chatgpt. But for us, it's not clear that any of the new stuff is going to be a huge leap over what we could have done like 3 years ago.
I think that's all right. So I think that's true for like especially the embedding realm.
Right. Yeah.
But if we're talking about like does NVIDIA's niche have extra room to grow in the future, given like where things are headed? That's like we need general AI to be able to like make better judgments in that than a human
For
or
sure.
a stock analyst,
Yeah.
right?
But yeah, I mean, as sort of as something you can sort of talk to and sort of get maybe insights on a stock specific thing, but like trying to scale that up to like a universe of 5,000 stocks, it's unclear how sort of useful this sort of individual stock level analysis would be for getting sort of common features that you can feed into a machine learning model. But yeah, for signals, maybe that's enough if you have the time and patience to ask about a good set of the universe. Yeah, and so someone's asking, wouldn't you need 20 years of timestamp news, and is that feasible? I think people are willing to sell you that kind of thing. It's not cheap.
I was gonna say, yeah, it's feasible but expensive. You can get versions of it, but it's probably not filtering out, because people can just scrape it from the web, sort of scrape it from Reddit or something.
Yeah.
But then you have like a lot of bot articles and things and like auto-generated stuff, and it gets quite complicated. So I think it's expensive to have it like properly filtered down into like reputable sources and things like that.
Yeah, exactly. And that sort of highlights the main point of all of this is like, you're only going to be as good as the data you use. And it's really the data that is the hard part, and is the LLMs and what sort of choices you make there is not the hard part. It's just getting the data in the right format and curated the right way such that you can actually generate good features from it. Is going to be like,
there is this, I have a hope that in ChatGPT 6.0, because you're training it on you're giving it like real targets and real future returns or outperformance or something, that it can accept bot articles. Even you don't have to do a good job of filtering, and it knows which it can just has a BS detector, and it can say, okay, this article is clearly bot generated. I'm not going to trust this very much and not put much weight on it. So the hope is, you can just give it the whole internet and it'll just figure it out,
yeah,
Give it 2 years, man, it's coming.
Some of the stuff about like these things being able to actually do interact with the internet and do searches. Yeah, maybe we don't need to do like fine tuning on like customized data sets. We just sort of ask it about each stock, and it will do an internet search and get all articles over certain time periods. And yeah, I mean, that's another tricky point about trying to use these things as features is if they're trained on all the data up to the present day, within the weights is sort of data from the future that you might be using to predict the past. And so trying to use these things without any leakage from the future to the past, it's really hard to know if you are or not, just because you basically have a whole internet somehow embedded in these weights in ways you don't really understand. And so it seems like their leakage is going to happen whether it is obvious to you or not. So trying to do a real back test using these kind of things is also extremely tricky.
Yeah. It seems like there's probably some way to like, Yeah, you can't like go back, and it's insanely expensive to make point in time LLMs for every like, year or something, only trained up on news data up to present. I mean, maybe you can do that, but maybe there's some other approach that has to do with like sort of you get some embedding from a Tesla article. But then you take but then you also just pass in like Tesla goes up in the future, and you take that embedding and you're kind of like regressing that out from the underlying news article. So you're kind of getting the embedding of like everything minus the knowledge that Tesla goes up in the future or something like that. I don't know. I'm sure you can do a lot with these sort of embeddings and try to get something that's maybe more realistic or at least safe.
I'm wondering how much of value added comes from the sort of LLM part of the LLM over basic statistics. I mean, if you just took a archive of headlines and just did statistics on keywords and stuff like that, and did some sort of sentiment analysis the way you would have done it 10 years ago, you could probably create some pretty good features that, I mean, the LLM is, you're sort of asking it to make an opinion for you or something that is probably not that much better than just aggregating.
There's
some,
a paper.
It's just counting, really.
There's a paper that like I think AQR put out kind of recently that was like basically just showing that there is alpha in just like headlines, keyword counting. But there's a lot of cases where you can show that obviously it doesn't work with negation. So whereas if you say not good earnings, it'll just maybe your statistics model will just see good earnings.
LLMs have been
but
shown
really,
to be bad at negation as well lately.
Yeah, I mean, AQR's paper was showing that they definitely outperform by a bit, but that it's especially in cases of negation. But yeah, it might depend a lot on like what exactly you're using.
Well, I remember something I did like 15 years ago when I was doing horse racing. Is you're trying to figure out features, and you've got all these numbers, and everyone's using these numbers, and there's a little comment that's written by the announcer, by the guy that calls the race, or by some sort of a human observer. It's just like a 3 or 4 word thing at the end of each running line on a horse, and it says, didn't pull up well, or just a little comment. And they use a jargon, so there's not that many words. I was like, I'm going to do a statistical analysis of this, and I'm just going to count these words, and I'm going to turn them into some sort of feature. And that was the biggest boon that I ever did. Just counting these. If it just had this one little word, the ROI on those features was through the roof. So I mean, if you're looking at stuff that no one's looking at somehow, it's not going to happen in finance. But I mean, I just wonder if the models are doing anything. They probably are to some extent, but I mean, it's just a lot of hype. You could have done a lot of this sentiment, 5 years ago, and it probably would have been 80% as good as LLMs.
I mean, 80% as good is probably true. But yeah, there is definitely alpha in closing that gap. I mean, Correlator just said the ChatGPT for stocks paper says that the vendor provided sentiment analysis underperforms compared to ChatGPT. I totally believe that. I've seen also a recent paper sort of comparing ChatGPT and some other older language models, especially ones that are fine-tuned to sentiment analysis. And the conclusion from that was basically that ChatGPT is a really good sort of general purpose solution. It's kind of a jack of all trades. But an older like BERT, like a FinBERT model trained on finance data, trained to do sentiment analysis on finance data, far outperformed ChatGPT at sentiment analysis. So a model that has been trained to do like a much smaller model is specifically trained to do what you want it to do can outperform even these much larger general purpose large language models. And this is using models from like 4 or 5 years ago. So yeah, I mean, there's no magic with LLMs. I mean, if these things are getting better at all tasks, but definitely like specialized models are still kind of dominate, it seems, at particular tasks.
I think what's one thing with like this sentiment analysis and why I don't know, a lot of times use for sentiment analysis and news and finance is like very short-term trading, like news drops. Can you trade on it and react to it faster than others by quickly just getting the sentiment and then making a trade? But yeah, and that, yeah, this like sort of just counting words or sentiment is really good for that. But yeah, obviously the promise of better, smarter models is like over a medium or long-term horizon. What does this news actually mean for like the underlying future of the stock and its future business prospects and how it fits into a model's like worldview? You could say that's like the hope. And I'm not sure we've seen anything close to evidence for that working yet, but that's my hope.
Cool. Well, I think we're pretty much out of time. I think we covered all the stuff we promised: aliens, LLMs, and rain features. So good job, everyone. Yeah, thanks everyone for showing up, and thanks Mike for being here.
Thank you. Great.